Good morning, mathematicians. Spectral sequence time. I realized my error from yesterday, I think. So, let's start there. Yeah. How are you doing? Everyone confused from yesterday? Did people figure things out? Who else have spectral and base sequence? Yeah. Good question. Where are we here? Users guide. Boom. Somebody guide me, because I'm about to get used. Wow, what am I saying? What are the words that come out of my mouth sometimes? I certainly don't know. Okay, so where were we here? We sorted out that one. Right, we had started on this. And I think I was hung up. Right, I was hung up on a statement here. I was hung up on this statement, and I think I sorted it out now. So let's start there. You can't believe that this is the first comment and thing that you hear on stream was literally about to say she's spectral in my sequence to like homology. Yeah. Well, yeah. Well, I guess we all think alike here. She turned the page on my spectral sequence until it collapses to the infinity term. That doesn't sound as good, but it's more accurate. Yeehaw, Rad, yeehaw. Okay, so I think the answer to my qualms was this. So what I was missing was just that we know that E infinity P0, so that collapsed on the n plus first page, and the n plus second and the n plus 2 page. And that is the cohomology of the map from En plus 1 P0 to En plus 1 P plus N plus 1 minus N. No, sorry. Minus N plus 1 here over the image of E n plus 1. Let's see, I've got it in my notes. P minus n minus 1 n to EP0. This was n plus 1 here. Yeah. And so the point was that this term is 0, actually. So that means that the kernel is everything. And this term, I believe, is 0 as well, just because it's 0 if Q isn't 0 or n. Oh, wait, crap, this one's n. No. I thought I had convinced myself why it was true. Because this should also be n plus 1. We know for n plus 1 and below, they're all equal. So definitely the top part. Oh no, it doesn't have to be 0. Nice. Okay, right. All right, this is fine. So we know that it is just en plus 1, but that's the same thing as e2. So this is ep0. And then we're modding out by the image of dn plus 1. Oh my god. Okay, yes. And that's exactly what we wanted. So... Okay, it only took, what, half an hour total thinking to get through this one sentence. I'm sure the next sentence will be fine. And so, right, so we have this quotient, like claimed. Since everything above this is trivial, we get that these are all isomorphic to the kernel. Lord Almighty. Everything above E star N2 just in the vertical direction? Okay. Right. Okay. So by I guess it's by like a similar computation here. It's saying this part will all die, and so we'll just be left with the kernel of this map here. Okay, I'm just gonna. That makes sense enough to me. I'm just gonna believe it. We've been good about doing computations this time around. Good morning, Ken. So this yields a short exact sequence. Okay, well, dn plus 1, I see. So this is just, right, this is just the kernel for the higher terms. This is just the definition of the map. Why is it exact onto here, though? Why is it exact onto there? Oh, by this computation of the quotient? Oh yeah, it's just by this computation of the quotient. Okay. You don't like how he calls it assess when he has 4 objects? Yeah, that doesn't make sense. But, I mean, what is a long exact sequence but just many short exact sequences glued together? Riddle me this, Batman. So, since our infinity page is non-trivial only in these stripes. Oh, he does say stripes, not strips. Okay. I thought maybe I'd misread that yesterday. The filtration on H takes the following form. Why? Okay, let's think. Why? I mean, F0 HP plus N is equal to F0 HP plus N F1 HP plus N? No, wait. No, wait. You're an African with IQ 75, but you want to be a physicist. You didn't find school hard. You got a degree, but just don't feel smart enough. Well, you got a degree. So, clearly you're smart enough for a degree. So, yeah. I mean, IQ is correlated with a bunch of stuff, including academic success, but correlation is not causation, and it's not an absolute damnation or absolute predictor of your capabilities. So if you want to be a physicist, then try to be a physicist. I mean, if you have a degree already, then apply for the next degree in that stage. Is it not a physics degree? Go apply for a physics degree. Yeah. You feel like you hear E infinity page and E2 page a lot, but not like E4 page. Yeah, well, I mean, E infinity could be E4 page. It could collapse by the E4 page. I think maybe why I'm here learning alongside you, Ken, so I don't really know, but my suspicion is that you generally don't want to have to compute a spectral sequence on the E4 page, right? Because that's nasty. You hope that it collapses by the E2 page. I mean, sometimes life is just hard, but, is the textbook going to show us the ugliest computation possible that would take 100 pages? Probably not. That's my guess. I have a degree. I'll be done my PhD in mathematics, Range Rover, in less than a year. The way I connect things is interesting and abstract. I connect disparate things. How do you do it? Just being obsessed with math for a long time and reading lots of math and writing lots of math. That's basically it. Yeah. And I've always just personally liked analogies in mathematics. And so yeah, I guess that's what I have a desire to connect these disparate things. Okay. Since the sequence is only non-trivial in these stripes, the filtration takes this form. But wow. This example's killing me, gang. Every sentence is a hard-fought battle to understand what's going on. What do you even mean, the filtration? I don't understand. So why are these two things equal? Well, I guess E infinity Pn is the quotient of F0 n is the quotient of these. So so is Pn. I could put P in here. Why did I move to 0? Oh, but I wanted to connect it to... Okay, so F 0 P plus N should be trivial. And so this is... and so these have to be... Well, either FP HP plus N is trivial. Well, in which case they're equal. In any case, they're equal, I guess, is the point. No, wait, I want F0. it's from your channel that you realize it's possible. You just need to really understand maths. They rarely connect that much. You failed math at high school, but you got into a chemistry program. You want to do masters in physics and switch. Math is weak though, so you need to work on it. Well, at least you got a clear understanding of what needs to be done. Got to grind hard on the mathematics. Grind hard on the mathematics. Okay. E0 P plus N. So that'll give me F0 HP plus N, F1 HP plus N. And that tells me that these two pieces of the filtration must be equal, which means that these two things are equal. And what does that mean? Does that mean, that means F0, right, and then that means that F0 and H1 and F1 are equal. Yeah, that tells me these pieces. Okay. I get it. Furthermore, we have this. Oh, every line in this example is killing me. In real applications, you wouldn't write it out so much in detail. It's not that bad, but it also takes some practice. Yeah. God, okay. And so we have the short exact sequence for each P given here. Oh. I don't know. I'm about ready to move on from this example. We did some computations. It's been fun, but the long exact sequence. Chaining these things together is called the Geisen. Right. We did read that yesterday. Let's go back. What was this trying to say? Okay, it says we have a long exact sequence here. HP to HPN2. Hello, Sergio Polar Bear. I see. So it's going down. It's going down like this. Okay. And we just keep repeating that in steps. Okay. I mean, I think this is a good example to understand. Do I try and convince myself of this final part? Well, I guess that comes from, maybe that comes from here. Maybe that comes from here because this, if you plug this into the quotient stuff, yeah, no, I don't know, whatever. I'm done with this example. Hello, Onage effects. Okay. What is a spectral sequence? Well, Sergio Polar Bear, you might want to get caught up with the... Basically, it's a bunch of graded vector spaces with maps between them. But if you want to get caught up, this book is linked in the description to this video. And the previous 3 episodes are all online. So, yeah, in short, a spectral sequence is a bunch of graded vector spaces with maps between them. And we want to take cohomology. Hopefully, clicking through this video and the previous ones will give you some sense of the yoga of spectral sequences. This is the introductory chapter, by the way. So I feel like chapter 2 is going to hunker down more, but I'm really looking forward to, we have an example coming up. It looks like we're not getting to it today, but I'm looking forward to example 1E. Here's a nice, really concrete example for those of you who are struggling in the abstraction. I'm sure I will come to resent it in due time. So I'm sure it will present its own complications, but okay. So it's often the case that H star, the target of our spectral sequence, carries more structure than simply that of a graded vector space. For example, when it's the cohomology of a topological space, it is a graded algebra via the cup product structure. Furthermore, if P is a prime, and we're looking at the FP coefficients, then this is a graded module over the mod P Steenrod algebra. Okay, that'll only come up a very long time from now. We discussed how one might determine this as a graded vector space. Through a spectral sequence, if it's a graded algebra, we can ask how a spectral sequence might determine the structure as well. To be precise, we first endow it with an algebra structure and determine what it means for the algebra structure to converge to H star. This will turn out to be a subtle matter. Oh, here we go again, gang. Here we go again. Though it has much rich rewards. Oh. Our suffering will be rewarded in due time. In 1.5, we'll take up the more difficult problem of reconstructing it from the bi-graded algebra. Holy moly. Okay. If we have a graded vector space, then HK, right, that's what we mean by the tensor. What does graded mean? Basically, it's just like just a sum and of subspaces with certain labels. So, for example, here is well, if you look at the first example. So polynomials, the ring of polynomials, or algebra of complex polynomials, I should say. If you go back and look at episode 1, this is an infinite dimensional vector space, right? What is a basis for it? 1, x squared, x cubed, ... forever. And one could define a grading on it given by, so it would be a grading over all the natural numbers starting at 1, where it's just the span, so the span of the monomial x to the n. So every vector can be written as a sum of those. So it's just like you give certain, labels to certain subspaces. So this would be an n grading. Or, for example, we could take this and we could give it a grading in two pieces. So we could just take the polynomials where every term is of odd degree, and the direct sum where every polynomial, where every term in the polynomial has even degree. So these are both subspaces, and the entire space is a sum of this. But that's also an example of a graded vector space. So you're just sort of keeping track of some sort of special labeling of subspaces, basically. Okay, so a 2 grading splits it in 2 subspaces. Yes, exactly. And then oftentimes we're interested in like operators or operations that preserve the grading or flip the grading or something like this. Yeah. Advice on real analysis. Do you need calculus first? No, you don't. Arguably, it could help for you to have some intuition as to what's going on, but in some sense, it's better to have analysis first because you understand what the hell everything actually means in calculus. At least in North America, we lie to our students and don't tell them what the limit is, nor the integral. You also wanted to ask which type of logic is used in all of pure maths. I'm not sure how to answer that. Well, certainly there's no one logic used in all of pure maths because some people study logic as pure math, which means they study other logical systems. But I don't know, first order logic, second order. Yeah, I'm not sure how to answer that question exactly. Maybe a logician would have a better answer for you. Can I give you a definition of tensor product similar to how I showed you direct sums? I can. So tensor product is here's the universal property of tensor product. So it's a what am I trying to write? The tensor product of V and W is a special space where for every bilinear map out of the Cartesian product, gotta plug in. For every bilinear map out of the Cartesian product, so it's a space together with a map from the Cartesian product into here, such that every bilinear map induces a unique map, making this diagram commute. But I will probably just refer you to a Luffy for more details on this construction, including a way to explicitly realize this as some sort of quotient space. So there's basically two ways to define this. One is to build this as a quotient of the free vector space on here, subject to relations, so that you basically end up with a bunch of symbols that satisfy like bilinear relations, like this. But the other way is you can also just define this to be the set of all bilinear maps. All bilinear maps from V to W? All bilinear maps from VW into the base, V cross W into the base field. Yeah. Yes, is just the tensor product. Although we're actually doing more fancy stuff. Predicate and propositional logic only? Probably not that only, but certainly those. Higher order logic is very commonplace in today's math, yeah. Yeah, classical logic, yeah. If you're working in some set theory, you can define most of the necessary quantifications just from set theory axioms. Yeah, I guess that's one way to say it. Okay. We're getting close to wrapping it up here, gang. Just FYI. So, right, we have graded algebra. If there's a mapping of graded vector spaces, called the product. It is a graded algebra if there is a mapping of graded vector spaces called the product. That is a linear map from there. The mapping must satisfy the following commutative diagram that expresses that the multiplication is dissociative. Algebra must have a unit that is expressed by this mapping, where K is the graded algebra, or K is the graded algebra determined by the field in degree 0 and 0 in other degrees. The mapping must satisfy the following commutative diagram. Sure. And one can Okay, so example one, consider rational polynomials as a graded vector space where the degree is given by the degree of a polynomial. It enjoys a graded algebra structure. Thoughts on Ramanujan genius? I'm not sure what else to say. Ramanujan was a genius, yeah. I don't know. I haven't studied his work in detail, but yeah. Monoid in the category of graded vector spaces makes sense. Spectral sequences actually form a category 2. Whoa. I guess that makes sense. And a multiplicative spectral sequence is a monoid in that category. Okay. I guess let's read this definition and then peace, maybe? It's a nice exercise to see that a commutative algebra with a grading is the same as a GM action on spec A. A commutative algebra. Is this some like Hopf algebra stuff? Is that what that is? Interesting. I could see the commutative algebra. Wait, why does the grading matter? That's an interesting thing. HOL? Huh? What do you mean, Hall? Where did Arad say Hall? Oh, higher order logic, I see. Okay. Suppose we have a bi-graded vector space, and then we're going to define a tensor product bi-grading. Holy moly. Okay. That makes sense, though. That makes sense. That's crazy, though. Yeah. You thought differential geometers had indice nightmares. I'm just gonna write this out once so that it maybe sticks in my head. So the PQ of this is the sum over M plus N equaling P, R plus S equaling Q of E, M, R, E, N, S. Okay. Higher order logic is a general term for systems we're allowed to quantify over all sets of elements, not just over elements themselves. So it's a bi-graded algebra if there's a mapping between these things. So, okay, and satisfies analogous conditions. Sure. As an example of bi-graded algebras, suppose A and B are graded algebras with their respective products. Then we let EPQ be this tensor product, and we define an algebra structure on there given by this composite. Right. Oh, and then we also have to put in a degree sign. Okay. The next definition. Okay, so we'll leave it there. We will leave it there with the Leibniz rule coming up. The idea is that the endomorphism of the torus are the T is T maps to TK. Right. Right. Well, those are the maps from the... Right. Right. Yeah. And now the kth graded summand of A is the eigenspace for this character. I see. That is interesting. That is cool. It still amazes you there are literally different foundations of maths, like type theory and category theory. The problem is still not solved. Well, it's not that there's any problem to solve. It's not that there's any problem to solve, and that different foundations mean the problem is not solved. First off, categories theory is not really a foundation of mathematics. I mean, there's ways that you can talk about, ECTS, or, you could take, the topos to be like a universe of sets, and there's ways that you can build categorical foundations of mathematics. But I would not, I disagree with the statement that people say, oh, category theory is a foundation of mathematics. Like, not really. Like, in the way that most people use it, like, it assumes set theory. Again, there's ways to, like I said, there's ways to make categorical foundations of mathematics, but I just don't like the blanket statement that, oh, category theory is a foundation. But also, so first off, in some sense, the problem of finding a good foundation of mathematics is about as solved as it could ever be. We have one. We have more than one, which is fine, right? But we just wanted some foundation. I mean, of course, a bit of a crisis. We can't prove its consistency, so, we have to accept it on faith. But, okay, once you learn that fact and you get over it, then... okay, set theoretic foundations are pretty good. Type theory, yes, type theory does provide another foundation of mathematics. Yeah, that's definitely true. But it's not, there's no sort of problem remaining to be solved in the sense of like, oh, we need a good foundation of mathematics. Now, there's still problems in the foundations of mathematics, in the sense of like there's questions that we have about what's actually provable in certain foundations and what's not, and philosophically certain foundations seem to be better for certain things than others, but am I not worried about certainty of math? No, not at all. I mean, look, so the thing is, yeah, there's no such thing as the ultimate foundation of mathematics. Some axioms are more useful to take for modeling the real world than others. We could say that, but it's not like there's some sort of absolute hierarchy of determining that. I don't believe that there's any absolute system of axioms that is like the true axioms of our universe or something. Yeah. Is ZF consistent? Again, we'll never know. And we'll never know unless it's not and we find a counterexample. But somehow it's inconsistent, and we've gone all this time and just happened to not find a contradiction. My credence on that is plummeting. So I'm not that worried. Yeah, I'm not that worried about it. And if anything, the rise in the use of proof assistance like Lean is making me even less worried, because now we have more, that gives me more assurances in our proof. Is that why also differential geometry has different axioms? Well, not really, right? Not really, because it's all under the axioms of set theory. So, I mean, differential geometry. So everything, pretty much everything in differential geometry. Again, like ignoring that sometimes we have to go beyond ZFC a bit for certain categorical considerations, but like everything in differential geometry can still be formalized in like ZFC, maybe plus some large cardinal axioms. There is an approach called synthetic differential geometry, which says, you know, we ignore the set theoretic foundations and we just assume a different set of axioms, and those axioms are just codifying differential geometry. And we can work with those axioms. But those axioms defining synthetic differential geometry are actually things that can be proved from the foundations of mathematics about like certain models of differential geometry once we set it up. So, yeah. Okay. Anyways, I said like 7 minutes ago that I was cutting it off, but then, but then we started talking about philosophy and foundations, and I'm a sucker for that. So I'm going to go now for real, until tomorrow. We will come back to more spectral sequence stuff. Until then, QED. Sorry, I see your comment right there at the end, but we'll chat about it tomorrow, okay?